Beginning of uncertainty. Werner Heisenberg. It is very common for most people to be confused by the uncertainty principle or find it not credible because it breaks with common sense. But it doesn't only happen to non-specialized people, it also happens in the professional field. Einstein, one of the greatest physicists, did not believe in the uncertainty principle. What does common sense tell us about things in relation to the speed and position of objects? Classical physics, in tune with common sense, tells us that we can precisely know the position and speed of objects. But the same would not happen in quantum reality, since this certainty would be broken. For the reason that particles have a dual nature. They are particles, as if they were small energetic points, but they are also waves that propagate, like those we see in water. Particles in wave mode have a peculiarity. They radiate indefinitely through space. This question is the key to understanding uncertainty, since to know the positions and speeds, it will not depend on the precision of an instrument. It simply cannot be measured, because a range of probabilities is generated, whether due to speeds or positions. This quantum situation generates an indeterminacy. To understand it, it is necessary to go deeper. It is possible to generate an accumulation of waves of variable lengths, which can be combined to create an average wavelength across an interference pattern. This average wavelength is called the wave packet. The more waves are combined in the packet, the more precise the particle's position becomes, but the more uncertain its momentum, path, becomes because more variable wavelengths are added. On the contrary, if a more precise pulse is desired, fewer wavelengths are added to the wave packet. Therefore, the position will become more uncertain. Therefore, there is no way to accurately locate, at the same time, the speed and position of a wave particle. I'm going to start with a series of questions and try to answer them briefly, since they are what help us overcome the Heisenberg uncertainty that is associated with a chaotic universe. Is the universe a product of the indeterminate motion and position of particles? A conclusion cannot be reached, you see, considering certain characteristics of the particles and excluding others. Since if the context is not taken into account, conclusions about the principle can be a false relationship between the event, the principle that describes it, and the conclusion. An analogy will help get the point across. Let's imagine a soccer game that lasts 90 minutes. The movements the ball made during the game are many. Now I am going to use only the movements that the ball made. Therefore, I will extract the entire context of the soccer game and ask you to imagine a computer screen, which will represent the movements that the ball made in the match. What will be done is the following. As if it were an animated movie, we will speed up the entire 90-minute sequence so that it lasts only 2 seconds, figure 1. What we would observe is a ball moving very quickly from one side to the other randomly without being able to simultaneously know either the speed or position of the ball due to the speed with which it would move. I want to clarify, due to the particularity of the uncertainty principle that explains quantum complexity, every metaphor only tries to get closer to understand it. Well, in this case, you can put a slow motion, and you can get to know the position and speed of the ball. What would lead us to conclude, if we were not told that it is the movement of a ball in a soccer game, that what we are seeing is also indeterminate, chaotic? In Figure 2, the movement represents a particle wave, which moves in a figurative coded space, where the particles would move determinately. The uncertainty principle uses two factors to obtain a universal. It was seen, through the metaphor, that it does not take into account the context that is essential to take into account. The necessary question is, do particles reduce only to positions and velocities? If the particles were only reduced to positions and velocities, the principle would also be valid. It would allow us to obtain certainty about the functioning of the fundamental structures of the universe. The truth is that this question is not correct, given that particles also have structure, function, properties, and interaction. The most important thing is that beyond the different positions and speeds of the particles, they in no way affect the properties, functions, structure, and interactions. The partial conclusion regarding uncertainty, due to positions and velocities, does not indicate that the universe is even indeterminate in its fundamental structures. The uncertainty principle can be used to argue that the universe is chaotic. But another relationship can also be made, because the speed and position data are not enough to show that the universe has been the cause of an indeterminate force. In Figure 1, I made an analogy with a soccer game. The need to understand the uncertainty principle in a context is argued. Since particles are parts of the universe, It is necessary to add the environment. I understand that the necessary factor can be taken from a moment in history, more precisely from ancient Greece, and from a philosopher in particular, Heraclitus. At least, Plato referred to them as his phrases. You cannot bathe twice in the waters of the same river. Or, everything flows. The change factor clarifies why the indeterminacy principle is incorrect, and it also explains the universe itself. Indeed, the universe and everything that exists within it is subject to constant change. For this treaty, all transformation is through the process of development through information. The point is that change in quantum and macro reality occurs at different speeds, since not all systems change at the same rate. Well, if that were the case, there would be no structures or laws. The uncertainty in the particles does also affect the structure of the particles. The configuration of the particles would change, and the universe would also be in a constant transformation. When he described a universe that, like us, ages through changes, these transformations affect the fundamental structures in a minimal way. I argued that, if we had a quantum scale, we could find pulses in the structures of the particles that would generate a slight transformation, which would be absorbed because they have a range of tolerance to change. For this reason, the alteration would not affect the structure of the particles. This point is important to understand the principle of indeterminacy, because if we wanted to measure everything that exists, which is not only position and speed, but also changes in structures, functions, and interactions in the universe, the same thing that the uncertainty principle predicts would result. For example, let's think in mathematical terms about a living system like the human being. So we have a system with a value of 100% that applies to the entire system. The human body is very complex, given that we have a biological nature which is made up of a set of cells that interact. But cells are made up of organic molecules, which in turn are made up of atoms, which are also made up of quantum particles. Finally, a complex system like intelligence, everything interacting. In this system, different changes can be observed at different pulses. The important thing to keep in mind is that the entire system is changing, and if it could be measured at quantum levels, the uncertainty principle would appear. Since you could not measure a system that is constantly changing to determine position, speed, structure, function, and interaction with precision. For the reason, by having a measure regarding the condition of a system, how it is changing permanently. When trying to obtain a precise measurement, it is not achieved, for the reason that said system has already changed. As for the percentage compared to the human being, if we start from data from the entire system, in the range of 100%, as soon as we finish the measurements it changed. But this change does not affect fundamental human structures, since we remain human despite constant change. Therefore, it is not possible to measure the characteristics of a system if it were to change constantly and at a pulse of quantum time. For example, let's think of a geometric figure that also had a color. How could we obtain both characteristics and with precision, at the same time, color and shape if they changed quickly and constantly to indefinite shapes and colors? This type of change would be one that affects the structure of the object, so we would speak of an indeterminate and chaotic entity. Because the structure responds to a changing quantum activity that does not allow said object to have a stable structure. But suppose the object has a well-established color and shape, it is a green circle that would be in a macro frame. In other words, in which we humans experience directly. Now let's think that things happen in the figure that we cannot see with the naked eye. It is the quantum field in which the atoms that form both the color and the figure are in constant interaction. Therefore, the color and shape at these levels are in a continuous transformation. So, the color and shape that we see does not allow us to be certain of the shape or color, because there are ranges that do not allow us to accurately measure their characteristics. The important point is that said probability range, in which both color and shape, although they do not allow certainty, do not significantly modify the figure and color that we see. If we humans had eyesight and a brain that captures the entire cone that makes up reality with absolute precision, we would not see structures or colors, or anything defined. I ask, how could we live in that world? The essential thing to note is that quantum perturbations do not change the fundamental structures of the universe in which we live. As seen in the example of the geometric figure and its color, its shape and color cannot be determined, neither quantum nor macro, by the constant and rapid pulse of the activity in which the object is found. Therefore, A universal conclusion cannot be obtained, as I already stated, from two characteristics when they are a part and not the whole. The indeterminacy that is interpreted through the Heisenberg principle does not necessarily lead to thinking about a chaotic universe. It would be a false relationship because all the other parts that make up the particles and the context are missing, which is what connects all reality, quantum, and macro. For those interested, you can purchase the book, Information Development Theory, author Pedro Bermejo, Amazon store.